Earlier, we showed you what happens when the hydrostatic pressure of the mud in the well is less than the formation pressure in a porous and permeable formation. Formation fluids flow into the wellbore. This is a kick. If not detected early, and if the rig crew fails to take proper action, well, you know the result. Yep, the well can blow out. Flat get away from it. A blowout can release poisonous gases, cause pollution, and of course, cause a fire. So it definitely pays to know what causes kicks and what to do if you get one. Let's talk about causes first. Causes of kicks include failure to keep the hole full of mud, swabbing, surging, lost circulation, mud weight not heavy enough, abnormally pressured formations, and annular gas flow after cementing. Let's look at them one at a time. When you trip pipe, you're pulling steel from a confined hole, which is the wellbore. It's just like taking a steel rod out of a cylinder full of mud. Notice how the mud level falls as the rod is removed. The same thing happens when you pull pipe. The mud level in the hole falls. And one thing hydrostatic pressure depends on is the height or depth of the mud column. If the level of the mud in the hole falls, the hydrostatic pressure it exerts on the bottom goes down. Less mud means less hydrostatic pressure. And less hydrostatic pressure means that formation fluids from a porous and permeable formation could enter the wellbore. If it does, it's a kick. So it's very important to keep the hole full of mud as you pull pipe from the hole. Crew members must ensure that enough mud goes into the hole to replace the pipe pull. Here's another wrinkle to watch out for when pulling pipe. Drill pipe in the hole is like a piston in a cylinder, or like a syringe a nurse uses to give you a shot. Pulling on the plunger pulls medicine into the syringe. Same thing can happen in the well. The bit acts like a piston and pulls formation fluids into the well. This is swabbing. Swabbing can lead to a kick. If the driller pulls the pipe too fast, the pipe and bit swab formation fluids into the well. Swab enough fluids into the well, and they reduce the mud's hydrostatic pressure. Eventually, formation fluids dilute and reduce the mud weight enough to allow formation fluids to flow into the well on their own. The well kicks because formation fluids have reduced the mud's hydrostatic pressure. When running pipe into a hole, the opposite of swabbing can happen. It's surging. As the bit and pipe go in, an increase in pressure, a surge occurs. If the driller lowers the pipe too fast, a strong surge can occur. If the surge is strong enough, it can break down or fracture a formation opposite the bit. The result, mud flows into the formation. The mud level drops, which reduces hydrostatic pressure. Consequently, a kick occurs. And speaking of formation breakdown, it leads to lost circulation. Surging is not the only thing that causes it. For example, if the mud's hydrostatic pressure is higher than the fracture pressure of a formation, hydrostatic pressure fractures or opens the formation. Mud then flows into it. Mud level in the hole drops to reduce hydrostatic pressure. A formation higher up the hole can kick. Another thing that can lead to a kick is the mud's weight not being heavy enough to balance formation pressure. For example, here's a hole with a TBD of 8,946 feet. Notice that the bottom of the hole is opposite a porous and permeable formation that contains fluids. Formation pressure is 4,900 psi. The hole is full of 10-pound per gallon mud. But the 10-pound mud exerts a hydrostatic pressure of only 4,652 psi at bottom. 10 times 0.052 times 8,946 equals 4,652 psi. So formation pressure is 248 psi higher than hydrostatic pressure. 4,900 minus 4,652 equals 248 psi. This well will kick. That is, formation fluids will flow into the well bore. The mud weight is not great enough to contain formation fluids. Earlier, you saw what happens when a formation does not outcrop to the surface. Overburden pressure creates abnormal formation pressure. Pressure in the formation is not relieved. It cannot escape. Abnormal formation pressure can be the source of a kick. The well kicks if the mud weight is not heavy enough to develop enough hydrostatic pressure to balance the abnormal pressure. Casing in a well protects the formations. Cementing the casing in the hole supports the casing. And a good cement job keeps formation fluids behind the casing from migrating, moving out of a formation and upward. But just like drilling mud, cement has to develop enough hydrostatic pressure to keep formation fluids in the formation. If the cement is not heavy enough, formation fluids can enter the annulus, the space between the casing and the hole. This is a kick. This is annular flow after cementing and can be bad news. So during a cement job, you may be told to keep an eye on the annular or casing valve. This valve is usually on the casing spool under the rig floor. You check it to make sure no fluids flow from it. If they do, notify the driller at once. You've got a kick behind the casing, annular flow. With all this talk about kicks, you also need to know that the rig crew sometimes intentionally lets formation fluids flow into the well. For example, the crew on this rig is running a drill stem test, a DST. They're lowering special valves into the well, which when opened, allow formation fluids to flow into the drill stem. It's a way of testing a well to see if it's a good producer. And to complete a well, when crew members install special downhole and service equipment to produce the well, they often intentionally allow formation fluids to flow into the well. Allowing flow into the well during completion operations is a routine part of the job. And finally, you may work on a well that the company is drilling underbalanced. In underbalanced drilling, UBD for short, the crew intentionally drills the well with a lightweight fluid. That is, the drilling fluid's hydrostatic pressure is intentionally less than the formation pressure. So formation fluids flow into the well bore and to the surface. The flow is controlled at all times. It's not just blowing wild. Here you see it flowing from a special pipe or line called the bluey line. UBD allows fast penetration rates and other advantages. To summarize, you've just seen several causes of kicks. Failure to keep the hole full, swabbing, surging, lost circulation, mud weight not heavy enough, abnormally pressured formation, and annular gas flow after cementing. And you saw that sometimes we intentionally let formation fluids flow into the well. We let flow occur during drill stem tests, during certain completion operations, and when we're drilling underbalanced, performing UBD. Next, we'll talk about kick indicators and kick warning signs. But for now, stop the tape and work exercise 2. After you finish the exercise, start the tape again to continue.